Semester 1. Today's lesson comes from Chapter 1 in your book. We'll be looking at Section 2 of that chapter on pages 12 through 14. Our objective will be to learn to identify and draw models of points, lines, and planes, and determine their characteristics. Because geometry is the study of points, lines, and planes, and their relationship to each other. Everything we see contains elements of geometry. Even the painting below is made entirely of small, carefully placed dots of color. Each dot in the painting represents a point. A point is the basic unit of geometry. The shoreline in the painting represents part of a line. A line is a series of points that extends without end in two directions. Here are some things you need to know about points. A point has no size. Points are named using capital letters. The points at the right are named point A and point B. Here's what you need to know about a line. A line is made up of an infinite number of points. For any 2 points, I can put an infinite number of points between them. The arrows on either end show that the line extends without end in both directions. A line can be named with a single lowercase script letter, or by 2 points that lie on the line. The line at the right is named line AB, or line BA, or just line L. Make sure, though, that L is written with lowercase script. The symbol for line AB is to place a line with arrows on both ends over 2 of the points that are named on the line. Let's look at some examples. We're given a line here and asked to name 2 points on that line. 2 points are point P and point Q. We're then asked to give 3 names for the line. Any 2 of the points on the line or the lowercase script letter can be used to name it. So, 3 names might be line PQ, line QR, or line M. Can you name another point on line M? Point R is also on that line, isn't it? Can you give 2 other names for line M? There's several other names. Line PR, line RP, line RQ, or line QP are all perfectly acceptable. 3 points may lie on the same line. If so, these points are called collinear. Points that do not lie on the same line are non-collinear. Look at the example given here and name 3 points that are collinear. We see that D, B, and C lie on the same line. 3 points that would be non-collinear would be A, B, and C. Can you name 3 other points that are collinear? Yeah, A, B, and E are on the same line. How about 3 other points that are non-collinear? A, B, and D would be an example of non-collinear points. Rays and line segments are parts of lines. A ray has a definite starting point, and it extends without end in only one direction. The sun's rays represent a ray. A line segment has a definite beginning and a definite end. Here's what you should remember about a ray. The starting point of the ray is called the end point. A ray is named using the end point first. Then name the other point on the ray. The rays at the right here are ray DF and ray CA. The symbol for a ray is similar to the symbol for a line, but there is only an arrow on one end of the line segment. A line segment has these properties. A line segment is part of a line. It contains two endpoints and all the points between them. A line segment is named using its endpoints. The line segment at the right is named segment BL or segment LB. Unlike a ray, it doesn't matter which order we name the points in. The symbol for segment BL will have a line over the top of BL, but there will not be an arrow on either end of the line. Do you see the difference between a segment and a ray? Name two segments and one ray in the example given here. Two segments would be the segment PB and the segment BC. One ray would be the ray PC. The ray PB would be another name for the ray PC. Your turn. Can you name another segment and another ray? We have the segment BD and we have the ray DB. The painting we looked at earlier in the lesson was painted on a flat surface called a canvas. A canvas represents a plane. A plane is a flat surface that extends without end in all directions. Here's what you need to know about a plane. For any three non-collinear points, there is only one plane that contains all 3 points. A plane can be named with a single uppercase script letter or by 3 non-collinear points. The plane at the right is named plane ABC or plane M. Remember, when we name a line, we use a lowercase script letter. When we use a script letter for a plane, it has to be uppercase. And remember that a line can be defined by 2 points. The plane requires 3. Points that lie in the same plane are coplanar. Points that do not lie on the same plane are non-coplanar. In the figure on the left, points A, B, C, D, E, and F are all coplanar. In the figure on the right, we have 3 separate planes that we can see. The points A, B, and C form one plane. The points A, B, E, and D form another plane. Points B, C, E, and F form a third plane. E is in both planes A, B, E, D, and B, C, E, F. Points A, B, C, and F are non-coplanar. Can you see that they would not lie in a single plane? Let's practice this. Look at the figure at the right and tell me 4 points that you see. There's lots of them. S, T, X, R, Y, M. Can you name 2 lines for me? Here are some options. How about 4 segments? Are you remembering to put the symbol above the letters? 4 asks us to name one ray who has an endpoint of M. There are several rays that have an endpoint of M. Just remember that the endpoint has to be the first letter named and that your symbol will be a line with just one arrow. 5 asks us to name 3 collinear points. Again, remember, that means they have to all lie on the same line. Y, M, and R lie on the same line, or S, M, and X lie on the same line. 6 asks for one point that is not on the line YR. 3 points, S, X, and T, do not lie on that line. Number 7 asks us for a segment with points T and M as its endpoints. There's only one, but we could have named it segment MT. Remember, with a segment, it doesn't matter which direction we start naming the points. 8 asks us for a line that does not contain the point R. That would be the line MX. How about a line that contains the point M? There's lots of them. Our last one asks for a segment that lies on the line YR. We could either look at the segment YM, or the segment MR, or the segment YR itself. Determine here whether each model suggests a point, a line, a ray, a segment, or a plane. How about a toothpick? What does that remind you of? I hope you said a line. It's got arrows extending in both directions. How about a floor? Yeah, that one suggests a plane. The tip of a pen? You've got it, that's a point. How about the surface of the water in a swimming pool? Well, if the surface is still and flat, that would be a plane. A beam of light from a laser starts at one endpoint, goes in one direction infinitely. That's a ray. And a fence pole has a definite endpoint on both sides of it. So that would be a line segment. Did you get them? All right, let's try drawing some of these figures. Take a piece of paper, draw and label a figure for each situation I describe. How about a point K lying on a line RT? Did your figure look like this? Let's draw a plane H, which contains a line A. Make sure you label them correctly. There you go. Now we want a line AB to lie in a plane M and contain a point R that's not on the line AB. Take a minute and get that drawn. Did your drawing look like this? Now we need a ray AX and a ray AY such that the point A is the only point common to both rays. There you have it. How'd you do? Did you know when to use a capital letter and when to use small letter when you labeled your figures? Did you remember to put line, ray, and segment symbols above the capital letters? For more practice, tonight do problems 1 through 30 on page 15 and 16 in your book.